So welcome everybody. And all right. Oh, start over. So I found this the other day. I'm sure if you have a smartphone, whether it's an Android phone or an iPhone, you could probably relate in some way, shape, or form. We're all using some form of security, I imagine. I know many of us were up till recently probably or may still be using 4-digit numerics. I must confess I am still using a 6-digit numeric code, although not yet to alphanumerics. I don't know if anybody's heard of the gray key, but I think there's something like a gray key or something along those lines, some type of device that's out there that can brute force 6-digit numerics pretty easily. Anyway, I just thought that was pretty funny. I showed this to my wife, and she said, took one look and said, he's definitely hiding something. It's quite possible. All right. Well, anyway, welcome to this webinar. My name is Andy Azure. I'm a solutions engineer at HashiCorp. And today I'm super excited to show you how you can leverage managed identities in Azure to authenticate to HashiCorp Vault and address the Secret Zero challenge. And we'll talk a little bit about what that means. So this presentation is building off of a blog post by one of my colleagues on our Solutions Engineering Medium blog, which we'll share the links to if you haven't already seen them. Great material there by the HashiCorp Solutions Engineering Organization. And there's quite a lot of posts. I think we try to do at least one a week, if not more. So his post was about how to use the Vault Azure authentication method for an Azure VM. And so I'm sort of building off of that work to show how you would do that with a platform as a service, such as Azure App Service or an Azure Function. Right, and the challenge is, so I have Vault for secrets management, which is available as open source or enterprise versions. Maybe you're already using that in your organization, or you want to use it. And but my workload needs to connect to Vault for the first time. I spin up a VM, an app service, an Azure function. How do I do that securely? Right? How do I establish that seat of trust or root of trust? And we'll talk about that. And again, this is built off a companion blog post, which has all of the materials and details in it. All right, so here's our plan for today for this session. We'll go over an introduction to HashiCorp for those that aren't super familiar with the company. I'll give an introduction to HashiCorp Vault, sort of cover the workflow, sort of level set for us. Then we'll review some of the authentication methods, focusing on the JWT or JOT authentication method, which is what we're using for this demo and webinar. I'll do a demo, and then we'll have time for questions at the end. So thank you very much. Let's go ahead and proceed. So before I get started, let's talk a little bit about who HashiCorp is and why you should care what we're doing as we're helping some of the largest companies in the world engage in digital transformation. So HashiCorp, since its beginning, has been leading cloud infrastructure automation. We have an entire suite of tools that were really started by our co-founders back when they were research students at my alma mater, University of Washington. Go Huskies, to meet the particular needs that they had on that project dealing with multi-cloud environments, right? And they had a particular itch. They needed to provision things and build things in multiple clouds, but none of the tools that were available at the time were meeting those needs. And so from that start, we now have an entire suite of products that allow you to build, secure, connect, and run any application on any infrastructure in any cloud. Right. And by leveraging that, we help companies unlock the cloud operating model and enable their digital transformation. So we're at just shy of 1,000 employees globally. Actually, I should correct that. We are just over 1,000 employees globally, and we're still growing. And as you can see, we have over 1,000 enterprise customers today. We're helping 70% of the Fortune 10, 80% of the top 10 global financial companies. We deal with a large percentage of the Global 2000 as well. So really impressive. You'll see some of the examples logos shown here in the background, just a few, but you can see that they're across all kinds of industries, manufacturing, retail, media, entertainment, tech. These are just some of the companies that are coming to HashiCorp and asking us for help to use our tools and help them further their digital transformation. All right, so I've used that term a couple times. What do we really mean by that? Well, let's talk about some of the trends that we've seen happening across technology over the past couple of decades, right? So, let's look at how things were done in the early 2000s, back when I first started in the industry. How were things built, right? Well, it was primarily physical traditional data centers, dedicated infrastructure. If you're running an application, it was running on a particular set of hardware, physical servers. You could go down to the data center, you could touch them, right? They lived in racks, you could go see them. But if you wanted to add new hardware, if you wanted to replace some broken hardware, things had to show up at a loading dock, right? That was kind of the hallmark of that time. Going to the loading dock, get loading stuff on a cart, unboxing, cabling up, racking, racking, stacking, cabling everything up, right? So that was really how things were. That was kind of the state of the art at the time. And as such, our processes for our application delivery were really built and designed around that flow of relatively static, relatively dedicated infrastructure. But starting in the mid 2000s, we saw the rise of virtual machines. So now you could make a new machine appear without ever physically going to a data center. Type a few commands, use a vSphere, for example, be 100 miles away from the data center, and suddenly you'd have a new machine. And then shortly after that, you started to see the rise of the public clouds, right? AWS, Azure, Google Compute Engine, where you could now provision an entire data center's worth of resources in a single afternoon. And that has really changed how we deliver applications, because now we have a number of different options for how we build things. And we tend to see the split today. Well, where we're seeing large enterprises especially maintain their private clouds, their on-premise, physical data center resources, and that's because that's where their systems of record tend to stay. This characterization is really promoted by Gartner, where you have kind of a systems of engagement, systems of record split, and so your databases, mainframes, the data about your core data about your customers tends to reside on-prem. But the systems of engagement, those end user applications, how you're interacting with your customers, how they're interacting with you, are being pushed out to the cloud. That's really primarily what's driving the public cloud adoption, because that's where you can move quickly. You need to move quickly with speed and agility to meet the demands of your customers and the market. So HashiCorp as a company was really born out of the multi-cloud era and the inherent challenges that it created. But there is another very important set of ingredients that heavily influence our product choices. And I kind of wanted to highlight that, which is we have a document on our website called the Tao of HashiCorp. And it describes kind of a set of foundational principles that we use as guides as we're going about evaluating trade-offs, developing and designing our products. And so first and foremost among them is this notion that workflows over technology. So our approach is to focus on the end goal and the workflow, as operators and practitioners that we're trying to accomplish, we're trying to achieve, and build backwards from there, right? And so as a result, we tend to be kind of technology agnostic, because we want to build a lasting enterprise. We understand that technologies are going to come and go. And so instead of focusing on a particular piece of tech, let's focus on that workflow. Focus on smoothing and making that an efficient, very usable, friendly workflow, and kind of build from there. So anyway, really interesting material. I definitely recommend you check it out. All right, with that, HashiCorp Vault. So a Vault is a secrets management solution for the zero trust era, right? So in a hybrid or multi-cloud world, we've lost our clearly defined network perimeters, the moat to our castle, so to speak. And kind of zooming out from that too, events of the recent past have shown that we can no longer assume the inside of our networks are secure, right? So Vault addresses this shift by providing identity-based access, and that's really kind of a core concept that Vault is built around, this notion of identity as a means of providing access, right? So it's also Vault is natively multi-cloud and hybrid cloud. That's one of the big reasons why enterprises choose Vault, is because it offers a single consistent API for your developers, whichever environment you're in, public cloud, private cloud, and so on, today or in the future, right? And it also has a very large variety of integrations and flexible methods, which we'll review in a moment. Speaking of developers, Vault being open source, we have a very vibrant and strong community around it today. This tool's been around a long time, and this is just a sampling of some of the libraries and SDKs that are available to integrate with Vault in your application. But in addition to these shown here, We also have some no-code tools, such as Vault Agent, highly underrated. I'd recommend you check it out. It doesn't really get a lot of coverage, but Vault Agent's a very, very underrated tool. And others like ENV console, and also our Kubernetes sidecar injector integration. So these are tools that allow you to integrate Vault with your applications with little to no changes to your application code. All right, so this is a diagram that you may or may not have seen either on our blog or in other materials. I'd like to spend a few moments on it just to kind of, it provides an overview of both, the workflow that Vault implements and a variety of sort of integrations that it has, right? So kind of at a high level, right, I'm going to take you through it counterclockwise initially, which is that, on the right side of the diagram, there's a variety of secrets engines that that are the secrets that you're using Vault to try to protect. And this is just a sampling to, there's a wide variety of different capabilities that it has. For example, the SSH CA pattern, or transit encryption for key management, encryption as a service, certificate generation, key value storage, of course, dynamic database secrets or static database roles, credential rotation, a variety of different secrets engines actually generating dynamic credentials for cloud accounts. So for example, an Azure service principal with a specific set of access that's good for a specific period of time, for example. So many different examples on that side. Then kind of moving from there, access is defined through granular through the use of policies, ACL policies, and those define, the level of particular access to specific paths that are allowed in Vault. And then moving from there, we're authenticating clients, whether that's a human user or, an application or a machine, by validating identity against trusted sources, right? And so on the left side, which is where we're going to be focusing today, are a variety of different authentication methods we can use to ultimately authenticate, validate that identity and issue a token. And so as depicted in the lower left, a token is the primary means of accessing Vault, a Vault token, and that's scoped to a particular level of access based on those ACL policies, right? So we're going to use some of one of these authentication methods to validate the identity of the requester. And once we've done that, issue a Vault token. That Vault token has a time to live associated with it. So already everything has a specific period of time that it's good for. And then it has policies that define what access is allowed. And so now kind of looking at it, kind of counterclockwise, that's kind of how the flow goes. And actually, I'm thinking about it now, we do everything clockwise. So maybe we need to rethink this diagram. But, kind of going through counterclockwise, we're going to verify identity. We're going to authorize access with policies. And then we're going to retrieve and return those secrets. So that's kind of the flow, consistent workflow that for interacting with Vault. All right. Okay, so let's go through a set of blackboards and kind of, go a little bit deeper on this, right? So traditionally, in a traditional access model, you have a set of credentials to access a resource. So you present your credentials and you gain access to that resource, right? That's kind of the traditional model. And what we're going to do with Vault is insert Vault into that flow, right? And Vault can become a gatekeeper that can do, has a variety of different secrets that it can protect. It has a variety of different authentication methods that you can use, and provides, central point of control with granular policy access and a bunch of other, capabilities and features, rich audit logging, of course, and things like that. So we insert into the flow, and whether I'm an individual, I'm a script, I'm an application, we can all use Vault. And the primary means of interacting with Vault is through the API. So whether I'm using the Vault binary, which is delivered as a lightweight Go binary that's cross-platform, or I'm using the API or the GUI, the web GUI, ultimately those will all be translated into API commands. And I'm going to now want to log in. The first step is authenticating myself. So, I'm going to go make a request to an API endpoint to log in. And as we covered, there's a variety of different authentication methods we can use to validate that identity, right? So whether it's AppRole, which we'll look at, which is kind of like client ID, client secret, but for applications and scripts, or Kubernetes auth method, which is my Kubernetes service account and namespace, for example. Or I can use a cloud identity, an identity document that is provided by, let's say, AWS or Azure or Google Cloud, right? And then based on validating that identity, Vault is going to issue the Vault token, which has a particular set of access within Vault based on the Vault policy that we define. And now I can use that Vault token to do part two, which is, of course, the fun stuff. Now I need to access some set of secrets, ultimately, whether it's a certificate generated, which we can do without, because we have that robust identity, we can do that without needing a CSR, really streamlined certificate generation, or I need a set of, service principal, for example, for my application. I can now present my Vault token with a request to say, I'm trying to access the secret at this path. Vault's going to consult and make sure that that access is allowed based on the policy. In Vault Enterprise, we also have an additional layer of policies that are under the term Sentinel, which allow us to do even more advanced things like IP CIDR checks, and we can even make dynamic external HTTP calls for other business logic. We can also do things like enforce MFA on particular secret paths, and other things. And then everything checks out, I'm going to get that secret, right? So that's kind of the workflow that we use with Vault. And as I mentioned, if you have any questions, I'm sorry, I forgot to mention. So if you have any questions, please post them in the chat or the Q&A function. And as soon as I'm done with the demo, we'll go over those questions. Okay, so back to this drawing. This is kind of the higher level view of what we just covered, and we're going to be focusing on the left side right now. Actually today, this session is really focused on the authentication methods, and so we'll review a couple of them now, right? So when we think about, okay, how do I spin up an Azure App Service, and that application needs to access Vault for something. How do I handle that initial delivery, right? That we sometimes call it secure introduction, or it's also called the root of trust or the secret zero challenge. How do I authenticate that entity for the first time? How am I able to give it access to Vault initially, right? So one of the ways that we do this is around the concept of response wrapping, right? So I could just generate a Vault token and give it to the application, okay? But there are some problems with that. First of all, that can be a manual process. Second of all, that's not necessarily maybe as secure as I'd like, because if I generate the Vault token, I can see what it is, right? And so now you've exposed that that sensitive material to whoever the intermediary is, whether it's an application or an individual. And so in Vault, there's a concept of response wrapping. What this enables you to do ultimately is deliver something from A to B without A being able to read that, right? So what it allows me to do is instead of generating just a token that I can see and give that to my application, I can generate a wrapped token. And that wrapped token, I am not able to see it. Only my application is able to see it. Really, it's a token that's stored within Vault. So how this works is I will generate a wrapped token, which is a token that I can use for a one-time lookup into Vault. I give that wrapped token to my application, and it uses it to access its actual token from Vault. And this is important because now we can, we can put some controls on that. For example, make it only good for a small period of time during our deployment pipeline window, for example, make it only available once, so that when my application goes to obtain its token using that wrap token, if it's errors or is unavailable, you'll immediately know that something has gone wrong, right? If that's some malicious party has grabbed it, for example. So let's take a look at how that works, right? So this is the one solution that you might use. And we're going to review this, then we're going to review AppRole, and then we'll review the JOT authentication method I'm using in the demo. All right, so here's an example, right? So whether that's me, the trusted orchestrator is, my pipeline, my configuration management tooling, or ultimately an operator, right? So, I request a wrapped token for Vault for application 1. Vault consults my, I present I'm the orchestrator. I present my token that has access to generate that wrap token. It doesn't have to be, and in fact will not be, the same access as the application, right? So this is a separate process that enables me to securely deliver this without having access to the application's secrets, right? So that's denoted in green. Okay. So what Vault's going to do is generate the red wrapping token, and there's a concept of a cubbyhole. Cubbyhole is a special place in Vault that only the application is able to read. Only the owner of that red wrapping token, right? So Vault generates the application's token, which is in orange, places that in the cubbyhole, okay, and gives the wrapping token back to the orchestrator. The orchestrator then delivers that wrapping token to the application, and now the application unwraps it. So it'll go to Vault and say, here's my wrapping token. I would like you to give me my actual token. And Vault does that and then destroys the cubbyhole, right? So it's kind of a one-time, can be a one-time use. That's a pattern we often see. So one-time use in a limited period of time, right? For the period of your application pipeline, deployment pipeline. Right. So now let's look at a scenario where there's a malicious party involved, right? So let's say I do the same process and I get that red wrapping token back from Vault, but it is intercepted by evil hacker, right? The evil hacker goes to Vault and says, here's unwrap this token and give me that orange token back, right? And it does. Well, as soon as the application tries to unwrap its token as well, it's going to get a 400 error, invalid request, missing or invalid data. And now we can immediately, based on setting up our logging and auditing, to flag on errors like this, we can immediately know that something has gone wrong, right? And so, you kind of think about like what's worse than being breached. It's being breached and not knowing about it, right? And so it gives us a method to know that we can deliver our root of trust to our application securely without being able to read it. But then if something goes wrong, we'll immediately know. Okay, so that's the first way you might do that. But that's not always going to work in scenarios where, you're on a platform as a service, for example, or a function as a service where, maybe there's autoscale involved and you don't know exactly how many copies of your application will be spun up, right? And so trying to guess like putting a number of uses on that pattern doesn't really work well in a platform as a service environment, right? And so there's another method you can use called AppRole, and this was designed in partnership with a lot of application developers around trying to solve these challenges. And actually, it's been around quite a while. And it's probably one of the most common methods. And so AppRole is you can kind of think of it like username and password for applications. And so what you'll typically do, well, actually, let's back up. So application, it's going to have a role ID and a secret ID. So like I said, it's kind of like a client ID and a client secret. It's going to present that to Vault, and Vault's going to verify those and issue a token, right, with the policy attached. And you can have many different, you can have, for example, for a particular role ID, you can have multiple, instances of that. So yeah, this is very, very popular. And what you'll typically do, how you'll typically see this used is separate the delivery of the role ID and the secret ID. So for example, your role ID might be something that is pre-baked into your application AMI, let's say through that, Packer, pipeline, for example, or if you, through how you're preparing your application image, right? But then the secret ID will be delivered separately through, for example, your application delivery pipeline, like CI/CD pipeline, right? And so that way, only the end application would possess both of those values, right? So that's another method that you can use, but it does require perhaps a little bit of effort, right? And so finally, we have the methods that allow us to leverage these trusted sources of identity. So in the case of Azure, for example, that's managed identity for Azure resources. And so this is how this works, right? So let's say we have our app service, and I cover all this in detail in the blog post. You can have a system assigned identity or a user assigned identity to your resources in Azure. So let's say in my app service, I've assigned it, I'm just using system managed identity. So then what my app service is going to do is query the Azure Instance Metadata Service, which, if you've seen it, it's like that, funny IP address, the 169.254.169.254, right? And we'll look at that in the demo. So my app service will query that instance metadata service and say, give me an access token, give me, something that proves my identity. And that's done with a JOT token. And so the instance metadata service, which again is part of the Azure platform, provides a JOT token to my app service. Then I can turn around and present that JOT token to Vault. And Vault is then going to verify that with Azure. It's going to say, I got this JOT token. Let's just make sure that this is actually valid, and it's, and this is done through the public key cryptography, where, this is a signed document that we can prove came from Azure. And once that checks out, I'm going to issue a Vault token to the app service that it can use to now access secrets within Vault, right? And so what's nice about this is that we can leverage this identity that comes from the platform, and we'll take a look at how that looks. But we can be confident that now this app service that's trying to access Vault is who it says it is, right? And ultimately, that's very important. Similarly, we have similar methods for other platforms. So I mentioned Kubernetes, right? We have that. We have for the other public cloud environments, for example, we have a similar method for AWS, similar method for GCP, right? So you can use the same pattern in those other cloud environments. And just to kind of round it out, there are a wide variety of authentication methods that are available with Vault. So really just depending on, this kind of gets back again to the, workflows over technologies, just try to provide a consistent workflow and seamless way to authenticate your workload to Vault wherever it lives, right? So if it's an Oracle cloud, or if you need to use, if it's on-prem and you need to use, if you want to use, if it's like IoT type of thing and you want to use certificates, for example, there's a variety of ways that you can ultimately prove your identity to Vault. Right. Okay. Demo time. Everybody, say a prayer for the live demo. Let me switch my sharing, please. Oh, wrong button. All right, here we go. All righty. You probably got a glimpse of my demo script there. That's fine. Let us. Oh, right. So I have already provisioned the Apple demo environment that's available. Again, link from the blog post, and we'll make sure that you all have the links if you haven't found them already. And so I've already provisioned it. Let's go ahead and get my outputs. This is what you'll see when you do is links to what the Vault server address is that you provisioned, how to SSH to it. So I hope everything's working great. Let's find out. Let's go ahead and SSH to there. Okay, yeah, so the machine is live. So this is the demo VM that is hosting our database, and it's hosting the Vault server. And what I've done is just put in a shortcut called load token. What this is gonna do is just load the Vault token into my environment so that I can go ahead and interact with Vault. One thing to note is that I provisioned the demo, the Terraform code, to go ahead and set everything up. So you won't actually have to do what I'm going to show now, but I thought it would be useful to just kind of step through it and show what it would look like when you're configuring the JOT auth method in Vault, right? So that's how you do it. Vault auth enable JOT. Now, if you want to specify other modifiers about what path it's located at, you can do that too. But for now, we'll just use the default. And so what I'm doing is configuring it with with an OIDC discovery URL, and this is where it's going to go fetch the public keys that it needs to validate the JOT. And I'm also saying that I'm only wanting to accept JOT tokens from my Azure tenant. Okay, and then I'm going to go ahead and what I'm doing here is, and this is all available in the script in the Terraform code, what I'm doing here is configuring a particular role. So for any given auth method in Vault, usually you'll have any number, from 0 to n number of different roles configured, right? So for example, a role per application. So what I'm doing here is configuring a particular role. I'm saying that I am accepting for this role, the JOT token must specify, bound audience of the default. Now, typically you would set this as whatever the address of whatever resource you're protecting. In this case, I was kind of lazy and I'm just using the default, which by default is management.azure.com. And then I'm specifying that, these parameters that come in the JOT token, must match as follows, right? So it must be from my Azure tenant. It must match my application identity, which comes, in my particular case, this is the identifier of the Azure identity for my Azure App Service, which you can find. Let's see, you can find it here. So I'll show you quickly, right? Usually that will be here in your, in your Azure portal, in your App Service. This is the system assigned identity for that, and you'll have a similar thing when you provision the Terraform code. Okay, and then I'm also specifying, so my tenant. This part, what we're doing is I'm taking in a few claims from the JOT that comes from Azure and mapping them into Vault's identity system. And the reason to do that is because now I can enrich the Vault audit logs with this information. And we'll take a look at that later. It's also covered in the blog post. And then so this is the web app policy for my web app that defines it's the ACL policy for the web app. So JOT type. And then I can also do things like, token bound CIDR. So I'm using this Azure, I think it's called regional VNet integration. I kind of cover it a little bit in the blog post, where I'm linking my Azure App Service to the VNet that hosts this demo VM. And so as such, there's an IP address, a source IP for the app service. And so I can actually limit the usage of this role in Vault to requests that come from that IP matching the app service. It's an additional layer we can add. And then, that's really it. Specify TTL. In this case, I've had it for 32 days. So typically, and this is a batch token. Batch tokens, I would also encourage you to check that out just for other added familiarity. By default, a token in Vault is what's called a service token. Service tokens can be revoked, right? But as a result, they incur, that they're a normal token that Vault on the back end, the Vault servers are tracking, right? A batch token is another type of token that is completely encapsulated. So it has a TTL, but it requires no write on the storage backend of the Vault servers, which means that they are very, very high performance. So if you have a type of workload that is maybe a function app that's going to be, invoked thousands, millions of times, I say millions of times, very, very high rate of utilization, then you might consider a batch token because they're very, very high performance for Vault to issue because they don't incur any writes, on the storage backend of the Vault servers. Okay, great. So that's what it looks like. Now let me go ahead, and that was I haven't actually submitted that payload, so let me go ahead and do that. Okay, so I've gone ahead and do that, and let's just read. Now we're going to Vault read the configuration that we just did, so you can see that it was accepted by Vault. That information is there, and then we'll go ahead and read the role, right? And so if you can see what I did here, I said Vault read auth jot role, the web app role, right? And so this is the role we configured that we want our web app to use, right? So you can see that all that information was stored in there. Now the part about the access token. Right. So as I mentioned, that funny IP 169.254.169.254, right? That's the metadata service within Azure that my instance can communicate to. And so let me show you what that looks like, right? And so this is curl request for this particular endpoint that's going to give me an access token from Azure, right? And that's what it looks like, right? So if you want to take a look, if you haven't seen this, I can just copy this. And then I can show you, I think it's in another tab here. I can show you what that looks like, on a decoded, right? And so this is a handy shortcut I found on the web that just, locally decodes that payload. And you can see, so there's if you can go read what this is about, but you can see it's a JOT token. This is the encryption algorithm that's used. And then these are all of the data that's contained within it. And so as you can see, this came directly from Azure. We can prove through the public key that Vault's going to fetch that it was, that it did come from Azure. And then it has all of these parameters that are encoded within it, right? And so you can see, for example, this one defines the the identity of my calling entity, right? So I was calling that from the Azure, VM, and it shows that here, right? So that's an example of what this access token contains. All right. And so now if I go to actually try to present one of those JOTs to Vault to try to sign in against my web app role, I'll show you how that looks, but we expect that to fail, right? So as we've defined on our web app role, we're only going to accept the identity matching the identity of my web app, right? So anything else is not going to be accepted. In addition, it has to come from that IP, right? And this is not, this is the VM. It doesn't have that IP, right? But so let's go ahead and see what it would look like. Oops. What it would look like if we did. All right, so here's a shortcut that just shows, Vault, this is how you would log in from the CLI. Of course, this is being translated to an API call. So Vault write auth jot login against the web app role, and I'm submitting as a parameter, I'm submitting one of those jots that came from Azure, right? But again, it's going to fail. We expected that to happen, but that's how it looks, right? And so the web app is doing a similar thing, and we'll take a look at that. So let's go ahead and set up our, let's take a look at our Vault audit logs, and we'll just keep that running, right? And so you can see this was the most recent request that we made. We made to auth jot login, and of course, permission was denied on purpose. All right, so let's go. Now what we'll do is let's go start up our web app. So what I'll do is restart it. Since I deconfigured and reconfigured the authentication method. Now it does take a few tries. So let me go hit some restarts. And what we'll do is we'll watch the logs, because the logs will show us, this is the logs of my web app, which will give us some additional information about what's happening, so we can kind of see under the covers a little bit. And just one thing to note, as I noted in my code repository, so I'll show you the blog. So this is my colleague, while we're waiting for that. Oh, actually, okay. So while we're waiting for that, this is the blog post that my colleague wrote. So if you have Azure VMs, I'd encourage you to check it out. He also covers Vault Agent, which I mentioned, is definitely an interesting tool you should take a look at. It handles all the client-side interaction for Vault. So Vault Agent, you can kind of think of it like as a Vault client that will then handle, it'll auto-authenticate to Vault and retrieve secrets, and then is able to render them in any like template format that you have, or populate them as environment variables, or just ultimately deliver them to your application without requiring you necessarily to make code changes to your application, right? You can think of it as a sidecar. And so this is his blog post. I kind of extended on it, and so this is the one I wrote. And again, there's links to there are links here to the code repository, which is located here. Should be, I tried to make sure that it was pretty clear and easy to follow. But you're welcome to reach out to me directly if you'd like any assistance or have any questions. My email address is just my last name at HashiCorp.com. Okay, so while that's running, looks like, let's see, did it work? Sometimes it takes a few tries to just spin up that container. So, oh yeah, the one thing I was going to mention was that this logging that I'm able to do here you have to turn it on. So I put a link in the repository down here that just says, you can view the web app logs after enabling logging, and there's instructions on how to do that. All right, so let's see. Okay, looks like we're up. I'm not seeing, oh, there we go. Okay, awesome. Do we have it? I wanted to show, oh, I guess I didn't get enough of the history. Let's see if I did. Oh, bummer. Well, I wanted to show, sometimes it's tricky to get it synchronized quite right. But if you do it, you should see I have in the code, let's take a moment to look at the application code. So this is the code that in the app service application that's actually performing this action. So what we're doing here is we're using the Azure Identity library. This is Python, and they have many, these a couple different versions provided, or different platforms provided. So in this case, I'm using the Python library from Azure to obtain an Azure Access Token, right? So this is going to go to that 169 address, the metadata service, and fetch a token. So here's what I do. I say access token. It's going to get a token. And then I dump it out to the logs. And so, if you do this in your environment, you should see that appear here. It's just sometimes, like I said, tricky to get the timing quite right with these. I'm not super familiar with the Azure web logs. So, but you can see that there's a bunch of debug logging here, and that's on purpose, right? So you can kind of see what's happening under the hood. So you'll get that JOT token here, and you can see. And if you look at our Vault audit logs, you can also notice all of the action that's been happening, right? By our web application, right? So you can see here, for example, this was the metadata I was talking about, where I have the application ID and I have the resource ID and the role and all that information contained in my Vault audit log. So this is, it's going to my SIM, it's going into my Splunk, whatever, what have you. All that information is there, right? So as again, this is the code. Get the JOT token from Azure, and then use that. I'm using Python has an HVAC client library. I'm using that to authenticate to Vault, and that's how I'm doing it, right? Just basically submitting the Azure Access Token here, right? So that's it as far as the authentication side, and then you might find the web app interesting as well. So this is something that one of our colleagues wrote a little while back, and it's just a handy application to kind of show a variety of different things, right? So what it's doing is this information is stored in a MySQL database, and we can show sort of the raw values that are being stored in the database compared against the decrypted values, for example, right? So we're using the Vault Transit engine to do encryption as a service. We're also using the Vault Transform engine, which is able to do format preserving encryption. So you'll notice here, for example, these social security numbers, they're the same format in the database, this as a social security number, but it is, you can see that it's encoded, right? So that's transform. And then we can also do masking with transform, one-way masking, and other things. So that's really the purpose of this demo application. But ultimately, I wanted to show how you can authenticate by using the Azure Managed Identity, and which enables you to avoid having to necessarily think about how do I deliver that root of trust to this application. I can, if it's running on Azure, I can use Azure Identity. If it's running on Google, I can use Google Identity. If it's running on AWS, I can use AWS Identity. And if it's running on Kubernetes, I can use Kubernetes Identity, and so on, right? So with that, I think I'll switch back. I think that concludes my demo. And all right. Cool. All right. So thank you very much for your attention. So I'd like to close with a little bit of a call to action. I'd really like you to take a look at the HashiCorp suite of tools, right? So whatever your familiarity, whether it's Terraform at the provisioning layer, Vault at the security layer, Consul at the networking layer and service mesh, or Nomad at the runtime layer, our tools provide consistent interfaces, workflows, and APIs that enable you to deliver your applications securely and efficiently in any environment, any cloud, with a single control plane. Right, I described earlier how our approach is to focus on the workflow, right? And how that pays off is our tools ultimately remove friction from your application delivery processes, day to day, month to month, those things add up. So let's use automation that enables you to work smart, iterate quickly, scale when you need to, and that can be both up and down, right? That enables you to be much faster and more responsive to your customers, and ultimately, you're able to be faster than your competitors and define your market. You don't have to take it just from me, though. These are just some of the organizations that have increased their IT velocity with our help. And again, it runs the whole gamut of industries and verticals, company sizes as well, large and small, manufacturing, automobiles, finance, insurance, media, retail, travel, you name it. We're helping companies become much faster and operate within this cloud operating model better than they were able to beforehand. So once again, thank you very much for tuning into this webinar. Really appreciate it. All right, questions. Let's go take a look. If I can get over there. Oh, all right. First question, and I apologize, it was it was while I was talking earlier. So, is Vault planning on offering a Vault as a service? Right? Not running. Yes. So, actually, yes. So, I would encourage you to take a look at the announcement earlier this year about HashiCorp Cloud Platform. It's very early. However, this fall, I believe we will have a private beta of Vault as a managed service on AWS Cloud, and then soon after, Vault available as a managed service on Azure and Google Cloud. So that is at least the initial vision, is we will have managed offerings of really all of our products. So Vault is first. Console is first. So managed console is available now on Azure. It's called the HashiCorp Console Service, and that is a fully managed, console service, like by our SREs. Like you pay for it through Azure, and so we're going to bring that same concept and make Vault available as a managed service. Again, our SREs, you just deploy a Vault cluster in a cloud that you specify. So that is coming later this year, and onward into next year. And then, and this will be expanded to the remainder of our offerings. So, so Nomad as well, right? A Nomad service, for example. So that's definitely coming. And in the future, they'll be available on something called HCP, or HashiCorp Cloud Platform, where you'll be able to both, sort of deploy and manage these services, and then also be able to federate and connect them. So, for example, if you need to peer across clouds or to your on-prem environment, you'll be able to do that there. So yeah, definitely thanks for that question. Coming very soon. It's going to be under the moniker of HashiCorp Cloud Platform. And so you can find more material on that. I also would encourage you to take a look next month, early next month. We're having our HashiConf sort of US. It's called HashiConf Digital October. That will be a full week of live events that you can view next month, and there'll be some significant announcements coming there as well. Another question was dynamic secrets already covered? Yeah, I didn't really cover it in this content. I really wanted to focus on the auto-auth method and how you would use how you would use the authentication method to authenticate a workload into Vault from Azure. So if it's a VM, you'd use the Azure method, and it's doing the same thing, and that's depicted in my colleague's blog post. But for this demo, I was using the auto-auth method, where we're taking that Azure JOT token, using it to authenticate to Vault. The demo environment does use database dynamic secrets. So when you say dynamic secrets, broadly, there's a couple of that's a concept that we apply in a couple of different ways, right? So in this demo, for example, we are using dynamic database secrets, where the application code is asking Vault for a credential to the MySQL database, and it's getting and then Vault generates a username and password to that database that's good for, I think, let's say 24 hours or whatever period of time, that has access to the particular database tables and things like that it needs for that application, and then gives that to the application. And so the idea there is that now we don't have to necessarily worry about rotation. We can be confident that if those credentials are, compromised, we can revoke them, but also they would only have been good for a period of time in the first place. And then we can also use that same pattern for cloud credentials. So as I mentioned earlier, you can do this, for example, for the Azure Service Principal, or if I have need an AWS Cloud Access key or what have you. We use the same pattern there, where Vault will generate, ultimately there is some root master account that you configure, right, that has permissions to do this, but Vault secures that credential. Then Vault will go to your Azure account and generate a service principal against on the role that you've configured, and give that to your user or to your application. And so now, for example, if I come in, if my application needs read-only access to a storage bucket for example, and I want to give it an access to that for 30 days at a time, Vault can do that for you. And it's completely, completely automated, very seamless. So that's another way you can do dynamic secrets. So the question was around, so there's another question. Thanks, Alexei. So just wondering, we have a micro. So the question is, we have a microservice architecture, several database clusters, and a number of databases on each cluster. Yeah, so typically, so for that question, the question is around if you have a number of different databases. I'll just describe, typically when you configure a database secrets backend in Vault, it's associated with it's a one-to-one relationship. So you'll configure a database secrets backend. It's configured against one particular database. So you'll typically need, you'll have, you can have many roles for that database, but if you have multiple different databases with different, they're just completely different databases, then you would need multiple of those secrets engines, and you can mount, you can have many different mounts instances of a secrets engine. And for further Q&A, I just please definitely reach out to me, azure@hashicorp.com, because I'd be happy to talk further about it. We just may run out of time here. And then, so the other question was, is there a way? Yes. So, okay. So the question is there a way to create a non-root token that never expires or doesn't need to be rotated for one of our core services, just in general? So yeah, there are a variety of ways. This is really interesting about Vault, as I've really gone deeper in my learning and exploration of HashiCorp Vault. There are always more than one way to do things. So it just speaks to the sort of level of controls and capability that it has. It's there are, so yes, so what you can do is there are two things. So one is maybe look at a periodic token. The other one is non-token that never expires. Yeah, so you can also do look at periodic tokens or orphan tokens. So depending on what you're trying to do, there's two things to take a look at. An orphan token is a token that's essentially orphaned and not associated with the parent. So because it's disassociated, that the expiration would be severed. And then also it may be a periodic token may work in that scenario too, but definitely take a look at those. Probably an orphan token. Yes, no worries. Thank you for the questions. Let me just check. Okay, looks like it's Q&A. There's just Q&A, not chat. Awesome. So with a few moments we have left, let me just go ahead and share the materials. Make sure that you all have the links. So just a moment. There we go. So this is the link, and it's in the Zoom chat. And I think we may also be able to follow up with an email for those that have registered. So this is the initial blog post that my colleague wrote. I'm sharing it here in the Zoom chat. This is the link to the blog post that goes into detail here on the and shares on the material that we covered today. The code repository is available here. Yeah, I think those are the key links. In general, I know these are kind of long to copy down, so just take a look at just Google search or DuckDuckGo, whatever your preferred search engine is, for the HashiCorp Solutions Engineering blog, which is, again, a great resource. You'll find stuff there. And then also, as I mentioned, the Vault documentation is available at vaultproject.io. Really great. The education team has done quite a lot of effort. So I'd really encourage you to check them out. The docs are available here. And soon they just added a new search capability. Find that very useful. Soon we'll also have version documentation. Looks like we have. Okay, so another question, is there a sane number of mounts and engines that should not be exceeded? Great question. So we just added, this is actually a relatively new documentation page called the Vault Limits and Maximums. This is not sort of exhaustive, so to speak. It doesn't contain every single limit and maximum, but it is a great starting point for some of the pertinent limits to be aware of as you're going about your Vault adoption. But so definitely find this as a reference. I think in general, I can't really suggest a number. I think it depends on your storage backend. It may depend on your storage backend, but ultimately, I don't think we typically see a significant. I wouldn't expect to see a significant, as long as your adequate storage is available. I wouldn't expect to see a significant limitation on the number of mounts and number of engines that you can really at this time. Vault's very scalable. It's more about, you may run into, if you're having heavy utilization, then you might need to scale in terms of transactions per second perspective, right? If you have a heavy utilization in that sense. But as far as like number of secrets that you can store, I mean, we're talking 7, 8 digits, millions, number of mounts and engines. I wouldn't be worried about it. Yeah. Well, thank you all very much for attending, for tuning in. A recording of this webinar should be posted and on our blog soon. And with that, everybody, thanks again. Have a nice day. Take care.